Great, so now that you're familiar with some of the components of a rocket, we're going to go over how to build a rocket in OpenRocket. OpenRocket is the software that we use to design our rockets. So let's start building. I've got just a new, fresh file here. And we start, obviously, with the nose cone, which is at the very front of the rocket. And here you can see the different shapes. We've got ellipsoid, conical, ogive. For now, let's do an ellipsoid nose cone, which is what we have in our rocket. We'll keep it very simple. And one thing you want in your nose cone and some other components, such as your transition, is a shoulder. And a shoulder is essentially an extension of whatever part the shoulder is part of. So in this case, we have our nose cone shoulder is an extension of the nose cone that slides into the body tube, and that allows it to be secured. I'll show you how that works in just a second. Let's first make our body tube, or our payload tube. Okay, so we'll keep this at 16 centimeters. And one thing you should know about this rocket in general in this demonstration, this is not going to be a good rocket in any sense of the word. It's not going to fly well. Things are going to break. This rocket's going to be incomplete. Please do not use this as a model. This is just simply for demonstration, simply to show you how OpenRocket works. So here we've got our body tube, or our payload tube, and that's because it holds a payload, which in our case is eggs. So we got our length as 16 centimeters, and I'll show you the purpose of a shoulder using this view. Now, as you can see here, I don't know if you can see, but this is our payload tube, and our shoulder just slides into it. It's slightly thinner than the rest of the nose cone. And that's what allows it to really stay inside our body tube. Now, one of the reasons I wanted to use OpenRocket is I want to show you what a transition does. We use a coupler, which connects two body tubes of different diameters. Of similar diameters. A transition, however, connects body tubes of different diameters. So while coupler is just one straight tube, a transition is two tubes. A more almost a cone-shaped piece. That's often a plastoid, and it connects two body tubes of different diameters. So let's make. There we go. In this case, our fin can will have a larger diameter than our payload tube. And one thing in transition, you also want your transition to have a shoulder. I'm just gonna make a shoulder. You want your transition to have a shoulder on both sides, but I'm just gonna make our fore shoulder, which is essentially the shoulder at the front. Okay, next we have our fin can. And this can be, we'll make it 18. And essentially, this will hold our motor tube. It will have the fins on top. It will hold our parachute and our shock cord, and is really, really important to a rocket. So in this, once we've selected this, we can add stuff inside it. I'm just going to add a centering first. Let's add it here. Okay, there. Really quickly, I want to show you let's choose a different, okay, there we go. So as you can see, this is the hole, and there will be a tube that goes straight through here. A tube with the diameter equal to the diameter of the hole inside the centering ring. Okay, so let's go back to our side view. And okay, our diameter is 3. So we can add an inner tube, also called the motor tube, because it holds the motor. And we want this diameter to be 3. Note that an actual rocket, it probably wouldn't be this big. I'm just going to keep it like this for now. And one thing you want is you want your motor tube to very slightly stick out of the rocket. And that's because at the end of the motor tube, where one end of the motor is, that's where there's going to be a lot of heat escaping. You don't want any of that heat to stay inside the rocket. So if your motor tube stays inside the rocket, then that heat is going to burn up the end. However, if it's slightly outside the rocket, then the heat's going to escape into the air. In our body tube and fin can, we can also add fins. Here, let's add, okay, here, let's add some trapezoidal fins. Keep it nice and simple. Okay. Remember, this is not everything you'd want in a rocket. This is generally how you'd build stuff, and how you'd really make a rocket, an open rocket. This open rocket has almost everything from mass components to parachutes to couplers to all kinds of fins. It really has everything you need. Let's go over the display really quickly here. We've got the length, the diameter, the mass with no motors. It bases this mass on the materials you chose and what parts you chose and their size and everything. It's got the stability. Again, this is not a great stability. Usually you want your stability to be between 0.8 and 1.2 cal. Our center of gravity, center of pressure, our apogee, max velocity, and max acceleration. These three are not applicable because we don't have a motor, so our rocket obviously won't go anywhere. Now, obviously I know you want to see kind of flight simulations and our motors, adding motors, and I'm not going to do that with this rocket. I'm going to show you a finished rocket, and we'll really go over that testing part, that simulating part, with our finished model. So here we've got Nishka's rocket. It's actually an earlier version of the one we have right now. As you can see, it still has a cone transition instead of coupler, which is just one of the differences. Let's just go over the parts really quick. So we've got our fin, we've got our motor tube, we've got centering ring number 1, centering ring number 2, engine block, got our launch lug, and our shock cord, parachute, transition, bulkhead, egg holder, nose cone, payload tube, fin can. Okay, now, as you can see in motors and configuration, go here, and if you want a new motor, you click, obviously we're in inner tube right now, because that's where we want our motor, and if you want to select a motor, you can just click select, and when you're choosing a motor, you want, 1, a company that you trust, so you'll have to do some research on that. Number 2, you want a motor that's not too expensive, and number 3, you want a motor that's not too powerful or not too weak. Some motors, if they're too powerful, will completely burn up your rockets. They're made for huge metal and plastic, really heavy rockets. On the other hand, some motors won't even get you off the launching rod because they're not strong enough at all. Okay, now let's go to flight simulations. Let's make a new simulation, and we can kind of simulate some conditions. Let's say it's a bit windy. Okay, let's plot. Okay. Oh, whoops. That was my fault. Okay. I did not specify a motor. Let's do that again. Okay, 1 second. Let's add an E28 for now. And we can, okay, let's say it's windy again. Let's plot it. Okay, plot. So here we can kind of see our altitude, our vertical acceleration, our vertical velocity. See the apogee, and let's just plot it. Okay. Now we're done. Let's see our results. We've got an apogee of 274, which is essentially 900 to 1,000 feet, I'd say, or maybe high 800s. You've got our total flight time is 43 seconds, and those two are really the more important figures. We've also, now one thing I want you to see is the E24 motor is actually weaker because our rocket goes only to 800 feet or 243 meters, and it stays up for less time. In this, we've also got a warning. And the warning is recovery device deployment at high speed, which essentially means something is wrong with our parachute. It either didn't deploy correctly or a rocket didn't separate at all. And that means that our rocket came down to the ground too fast. Great. So now that I've shown you this, you kind of know how to use OpenRocket. If you have any questions, or you want to see more designs, or you want to show us your own design, feel free to contact us at any time. Cool. Thank you.